The little thing. So the question here is, where is the heat flowing from the heat spot? So we can kind of try and draw a picture. Now remember, heat flows from hot to cold. The heat spot itself is a little bit complicated. Um, so it's going in all different directions, but it's going to go in the direction of the coldest. So if I'm looking at 100, I think it's going to flow down or up. Down, we're going to have to say. Yeah, in a big way, I'd say. And then is it going to go left or right? Well, I don't see much difference between left and right. So I think it's going to mostly be down. So something like this. So it's going to be a vector, I think, with a large minus y component and a large negative x component. So what we do, and I'm a bit, I'm wondering, is this where the two in the previous section that I couldn't figure out came from? But no, we're going to do rise over run here. So okay, slow down a second. So we have that the heat flux density is given by this formula here, but we can approximate the derivative of temperature in the x direction by doing basically rise over run. Now there's a formula there, but it's basically rise over run. So say temperature rate of change in the x direction. So we're going across 100. So let's go from 51.9 to 56.9. Right? So the change in temperature is 56.9 minus 51.9, and that spans two delta x's, so that's over 2 times 0.1. Okay, and that's equal to, we'll calculate a number here, 56.9 minus 51.9 divided by 0.2, I get 25. Okay, now I'm betting there's going to be a larger derivative in the y direction. So the derivative then in the y direction will go across these 2 points. Now actually, if we look at it now, maybe, yeah, okay. Let's go. So the derivative then in the y direction, so do rise over run. So the change in temperature in the y direction is 57.1 minus 51.8. There's not going to be much in this, divided by the change in y, which is 2 times 0.1. And this gives us 57.1 minus 51.8 divided by 0.2. I get 26.5. Yeah, very little in it. You see the 37.4, it doesn't actually play a role here. And therefore, the heat flux density at this point is equal to, so it's minus k, which is minus 0.5 times these, and there's an x and a y. So look, this is like a vector. And how do you multiply a vector by a constant minus 0.5? You multiply them both by minus 0.5. So the x one will go to minus 12.5 and the other one going to minus 13.25. Now it was indeed negative in both the x and y directions, but no more than that. You can leave it like that, or else you could write minus 12.5 I minus 13.25 j. Now if you want to use units, well, we can't, because there's no mention of units. We can't assign any units. So that's just a lovely little question. Now you might say, where the hell is that Q coming from? Well, that's Fourier's law. It says that the heat flux density is proportional to the difference in temperature. And we're just doing a rise over a run, but we're not going over a single delta x, we're going over a double delta x. Yeah, so that's everything for, I think, before Easter.